So I welcome you all to this channel. Today in this video we are going to see the divisibility rules in the chapter called numbers. So we would be focusing on the divisibility rules of 1, 2 and 3 in this video. Now before going on to the video, let us understand what divisibility rule is all about. Say for example, if I've given you a number like this, which is 789. Now without actually dividing the number, we are supposed to find if the number is divisible by either 1 or 2 or 3 or 4 or 5 or 6 or 10 or any other number for that matter. For example, I'm going to take 789. So 789, I'm going to divide this by 2. So on dividing by 2, I know I'll first take 7. So 3 2's 6. On reducing, I get 1 as my remainder. I'll bring 8 down, so it becomes 18. I know there are 9 2's in 18, so this is 0. And I will bring 9 down, and I know 4 2's is 8. And on reducing, I get 1. Okay, so which means I have 1 as my remainder. Now I will say that, see, since I get 1 as my remainder, I would say that 789 is not divisible by 2. So then when do I say a number is divisible by 2? When a remainder is 0, then I would say the number is divisible by 2. Same way, if I divide 789 by 3 and I get remainder as 0, I would say 789 is divisible by 3. When I divide 789 by 4 and I would get 0 as my remainder, I would say that 789 is divisible by 4. Same is the case for 5, 6 or any other number for that matter. Right? Now, without actually dividing the number by the concerned number given, we would be seeing the shorter strategies, that is the divisibility rules for 1, 2 and 3 in this video. We will come back to this slide again. So before I actually enter into the concept, I would just take another few seconds to explain what quotient and remainder is all about. Here in this example, I have divided 75 by 4. So when I say I divide 75 by 4, 75 is the dividend and 4 is my divisor. So on dividing 75 by 4, my quotient is 18 and my remainder is 3. So now you understand the differences between dividend, divisor, quotient and remainder. So this is nothing else but I would say that there are 18 fours in 75. Okay, 18 fours in 75, and also when I add my remainder 3, this gives my dividend, which is 75. So divisor into quotient plus the remainder gives me the dividend. So if my remainder is 0, then I would say this dividend is completely divisible by the divisor. So with this input, let's get into the divisibility rule of 1. See, the divisibility rule of 1 do not have any specific condition, because any number, any given number under the sky is divisible by 1. So when you divide the number by 1, it gives the number itself. So I had taken example of 3 here. Say for example, 3 is divisible by 1 and 3000 is also completely divisible by 1. Even 3 lakh is divisible by 1 and 3 billion is divisible by 1. So any number that you take is actually divisible by 1. So it does not have any condition. Okay, any number divided by 1 will give the number itself. Right? Now let's move towards the divisibility rule of 2. So in order to understand the divisibility rule of 2, it is quite important to understand the differences between even and odd number. So as you all know, even number is 0, 2, 4, 6 or 8 is all. That is a number ending in 0 or 2 or 4 or 6 or 8 is a even number. So that's what it's been given here. If a number is even, or any number whose last digit is an even number, the number itself is an even number and all even numbers are divisible by 2. In other words, if the last digit of any given number, the last digit or the unit digit of any given number is either 0 or 2 or 4 or 6 or 8, then it is completely divisible by 2. Let us see examples. Here I had given example as 600. I have taken example as 688. So in this number, the last number is 8, which is an even number. So naturally 8 is divisible by 2. So 688 is also divisible by 2. Whereas if I take the next example, 689, here the last digit is 9, which is not an even number, or I would say 9 is not divisible by 2. Therefore, this whole number is not divisible by 2. Can you tell me if 1111 is divisible by 2? Put your answer in the comment box. Before moving on to the divisibility rule of 3, let's understand what digital root is. So I have taken the same example 1111, and the digital root is nothing else but the sum of the digits of the given number. So here I have taken 1111, so the digital root is nothing else but 1 plus 1 plus 1 plus 1, which is 4. Moving over to the example. So this is indeed an example which can be easily counted. So 4, 2, 5, 3, 1, 1 is your example, and you're supposed to find the digital root. So you are going to add 4 plus 2, 6, 6 plus 5, 11, 11 plus 3 is 14, 14 plus 1 is 15, 15 plus 1 is 16. So since 16 is the sum of all the digits, but still I would not say 16 as my digital root, but my digital root is 1 plus 6. Again, I need to add these two digits in order to get a single digit. So ultimately, digital root is nothing else but you count all the digits or add all the digits and conveniently bring it to a single digit number, and that is going to be the digital root of that particular number. Now let's move for another example. Oh my God. So this is a bigger number which has 4259311659321. So by the time you add all the digits, you might as well lose a lot of time where you literally have to calculate it on. So for which I'm going to move to rule 2 when it comes to digital root. So in this rule 2, especially when it comes to digital root, number 9, see here you have number 9, which is supposed to be the hero of this concept called digital root, because you would be reducing the numbers or you would be removing the number 9s in any specific given number, or see here the definition says take out the number that counts to 9 or the number 9 as such and add all the remaining digits. So this is going to be quite confusing. So for which I'm moving over to the next to give a clear explanation. See here in this, the same number which is again be reciprocated. So as in the definition says, I'm going to remove all the number 9s from this. So here I have 9 and here I have 9. Now I can also take the number that counts to 9. That is on adding either 2 or 3 numbers that must count to 9. For example, say I can take 4 plus 5 that counts to 9. What else numbers do we have? 6 plus 3 that counts to 9. Again I have 5 I can take. So 5 plus 3 is 8 plus 1 is 9. So 5, 3, 1. 5 plus 3 plus 1 counts to 9. So I have removed that also. And then the remaining numbers are 2 plus 1 plus 2 plus 1. So let me take 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 1 is 6. So I tend to say that the digital root of this big number is 6. Okay, I repeat, the digital root of this big number is 6. Now you must be having a doubt. Why would I remove 9, or why should I remove the numbers that counts to 9? Not only the answer for this, but also the special or the importance of digital root is explained in another video, the description of which is there in the the comment box. You can go through it. Moving over to the next slide. Now let's go through the divisibility rule for 3. So here the reason for explaining the digital root before that is majorly focused here, because with the help of digital root we are going to explain the divisibility rule for 3. So again, before going into the divisibility rule, let me take the multiples of 3 and write it down. See, we all know 3, 6, 9, 3 4s 12, 3 5s 15, 3 6 18. Then the next multiple will be 21, 24, 27, 30, 33, 36, and it goes on. Okay, so if you could find the digital root of the other multiple, see, leaving 3, 6 and 9 because whose digital root is 3, 6, 9 as such, when I'm going to take the digital root of 12, 1 plus 2 is 3, 1 plus 5 is 6, 1 plus 8 is 9. Again, let me take a count here. 2 plus 1 is 3, 2 plus 4 is 6, 2 plus 7 is 9, 3 plus 0 is 3, 3 plus 3 is 6, 3 plus 6 is 9. So even if you take the other multiples of 3, you would finally end up with these three numbers, which are 3, 6 and 9 indeed. So I tend to say that a number is divisible, said to be divisible by 3 if its digital root is either 3 or 6 or 9. Let's take another example. So here is where 534921, and we are going to just check if this number is divisible by 3. So as I told you, instead of adding all the digits, you might as well can remove number 9s and the number that counts to 9. So I am removing 9 here. Then 5 plus 4 counts to 9. The remaining numbers are 3 plus 2, 5, 5 plus 1 is 6. So the digital root of 534921 is 6. So I would say that the number is divisible by 3. Since the digital root is 6, I would say that the number is divisible by 3. I'm coming back to the slide. So this is a quick check. Please do check and tell me what are the numbers here which are divisible by 1, 2 and 3. For example, if I'm going to take 789, I would say 789, let me erase this all out. I would say 789 is divisible by 1. It is not divisible by 2. And for 3, I need to remove this. So 7 plus 8 is 15. 5 plus 1 is 6. So it is divisible by 3. So ultimately 789 is divisible by only 1 and 3. Likewise, if you can just check for all these numbers and give your answers in the comment box. Thank you.